Welcome to EDU World Space.
In this problem, we're given that there's an aquarium that is filled with water, and the aquarium is 5 feet long, 2 feet wide, and 3 feet deep. And we're asked to find the pressure at the bottom. We know that pressure is equal to density times the gravitational acceleration times the depth. And we can actually write this one as lambda d, where lambda is the specific weight, which is just rho times g. And we know that lambda for water is 62.5 pound per feet cube. So all we need to do is to plug the knowns in. So P pressure will then be 62.5 multiplied by depth. So we find pressure then to be 187.5 pound per feet squared. In part B, whereas to find the force at the bottom of that tank, we know that force is equal to P times A, where A is the area that the pressure is acting on. In that case, A would then be the area of this shaded region. That would then be 187.5 times 5 feet times 2 feet. We then find the force at the bottom of the aquarium to be 1,875 pound. And in part C, we're asked to find the force at one end. So imagine we're looking at this aquarium from the side. So we would see this, that is 2 feet wide and 3 feet deep. Let's just assume that we have a thin strip, this guy, and then let's assume that this is dx. So the area or the force would then be P times A, where area is the main variable of interest. That would be 2 times dx, and we would need to then add those areas up starting from 0 up to 3. So area would be 2 times dx. Pressure again will be lambda times deep, where depth in this case assume that it is x, and let's say that we're measuring that x starting from the surface of the water. So that would be lambda times x. Combining those two, force would then be integral from 0 to 3, so surface of the tank, the aquarium, to all along up to the bottom of this aquarium, lambda times x times 2 dx. From this we see that then force would be lambda x squared from 0 to 3. That would be lambda times 9 minus lambda times 0, so that is 9 lambda, where we know that that is again 62.5 pound per feet cube for water. So we find then the answer to be 562.5 pounds.